In this video, we're going to be evaluating a difference quotient. Now, one of the basic definitions in calculus employs the ratio f of x plus h minus f of x divided by h, where h cannot equal 0. This ratio is what we call a difference quotient. So now we're going to go ahead and evaluate a difference quotient. So here we have for f of x, we're going to let, that's going to equal x squared minus 4x plus 7, and we want to find what is that difference quotient. So what we're going to do is we're going to go ahead and start off by plugging stuff in. So remember that f of x is all of this, right? So right here when it says f of x plus h, that means that everywhere that we see an x, we're going to need to put actually x plus h, because that's what we're plugging in, right? So we'll be putting this in that spot. And then here we'll be putting our original equation, original function there. So let's start off by putting that in. So we're going to go ahead and I'll do it in green. So we write our equation. So we have x squared minus 4 times x plus 7. And now remember that we're replacing that with x plus h, right? We're replacing it with x plus h. So we're supposed to take that, and then we're supposed to subtract that from our original equation, which is x squared minus 4x plus 7. And all of that is over h, right? So we're gonna need to FOIL or distribute, however you'd like to think about it, this piece right there, right? So let's go ahead and let's create a workspace, but let's put our workspace over here. Change my mind. So we'll put our workspace here. So we're gonna have x plus h times x plus h. So x squared plus xh plus xh plus h squared. So we can simplify that to x squared plus 2xh plus h squared. And we're going to plug that in to our spot over here. So x squared plus 2xh plus h squared. Then we need to distribute our negative 4. So minus 4x minus 4h. And then we still just have our plus 7. Then we're going to distribute our negative sign there. So I get minus x squared plus 4x minus 7. And that's all going to be over the h. Okay. Now remember, h can't equal 0 here because it's in our denominator. So now we're going to try and combine our like terms. So let's start here. Let's see, I'm going to use the blue to help me with that. So x squared, is there another x squared? Oh, there is right there. Oh, look at that. They're opposites of each other. So they will just cancel each other out. All right, let's take a look at that 2xh. Do you see any more xh's? Yep, me either. So we'll write down 2xh. Okay, and then we'll bypass that. So we've done that one. What about this h squared? Are there any more h squareds out there? Yep, I don't see one either. So we'll add that to our pile, to our list. All right, what about if we look at x's, just plain x's? Oh, here's one over here. And hey, those are opposites, so they'll just cancel each other out and go away. Let's take a look right here. So it looks like right here we have a negative 4h. And I don't see any other plain h's. So that means we get to write that in our list. And then it looks like we have a 7 and a negative 7. And those will cancel out. So we have our list. And remember, our h is in our denominator. And now let's go ahead and let's rewrite that so that it is in, well, no, it doesn't have to be in any real type of form. Might be nice though. But if we look at it, what do all three of those have in common? They have an h in common. So let's take out the h. So we're going to take out the h, and that's going to give us 2x plus h minus 4. And that's all going to be over h. And hey, we can cancel out our h's. Okay, that's great. So now we have 2x, oops, let's write that a little bit better, 2x plus h minus 4, let's write that a little bit better, minus 4, where h can't equal 0. And that's it, that's our answer. So that's how you evaluate a difference quotient. Now notice in this example that h can't be 0 because in the original, like it can't be 0 in the original expression, right? If we take a look at our h, with h being in the denominator, that means it can't be a 0, right? Therefore, you have to restrict the domain of this simplified expression. And that is why we have this h can't equal 0 right there. So don't forget to limit and restrict your domain if necessary.